All right, tonight or whatever time you're watching this educational video, we will be talking about instantaneous velocity. It is part of your culminating test or culminating evaluation this coming Monday. But before anything else, do not forget to, support or subscribe to this channel. There we go. So we will be discussing about instantaneous velocity. Before anything else, velocity is a vector in nature. So therefore, it has magnitude plus direction. So let's define what is instantaneous velocity. Here are the North Stars in knowing what is an instantaneous velocity, or we will agree that we will be using the symbol V sub inst to represent instantaneous velocity or instant velocity. It is the exact speed and direction, that's velocity. It is the exact speed and direction of an object at a single specific moment in time rather than over a long interval. Let's say, for example, what is the instantaneous velocity at 9 seconds? So we will just be focusing on that moment, on that specific moment in time, which is 9 seconds. So we have this formula here. If you're familiar with this, v of x is equal to dx over dt. And we can equate that one to our limit of change of x over change of t, wherein t approaches to 0. But yeah, let's not be so overwhelmed with this equation here, because we will be using the power rule to shortcut how to get the derivative of the position function with respect to time. By the way, when you will get the instantaneous velocity, always remember that it's the first derivative of the position function with respect to time. It's the first derivative. Okay? If you will have a function or a position function, get the first derivative, and that will be the instantaneous velocity. Okay, so as I said, there is a shortcut to get the derivative of the position function with respect to time. To represent our instantaneous velocity, we have this speedometer here, and of course, we have a compass. You say, for example, the compass points to north direction, and our speedometer reads, let's say, 120 meter per second. So you have your instant speed in direction. Let's say, for example, this particular readings happened at 160 seconds. So in this particular moment in time, 160 seconds, the reading is 120 and then north. It's like a snapshot of a certain moment. Let's talk about the power rule. As what I have said, it's the shortcut used to find derivative of a function. We have this formula here. It's the derivative of x with respect to position is equal to this formula. If you have this function here, you have your variable x. This is the variable. It is going to be your power, or let's say exponent. So if you have a variable and an exponent, just follow this formula here. If you can see, n, whatever the value of this n here, you just have to put it in front of the variable, and then afterwards you will have to uh, deduct one entity from that exponent n, or that value of n. Again, the formula is like, if you have this, let's say, variable of a raised to n, all you have to do is to put this n here, you multiply it with this variable, and then next is you will have to uh, deduct 1 from the exponent, and in that case you will get the derivative of a certain term or a function. Let's practice how to do it. For some it's just a review, but for others maybe it will help you in finding the derivative of a certain term or function. Let's say for a very simple function here, we have this x raised to 3. That's the function. To get the derivative of x raised to 3 or x cubed, prime of x or derivative of x or derivative of x cubed with respect to position, all you have to do is you have to put 3 here in front like this, 3, copy the variable x, and then remember this is n minus 1, right? So 3 minus 1. So our f prime of x of this is, or the derivative of our x cubed will become 3x squared. That's the derivative of our function here. Another example, let's say we need to get the derivative f of x is equal to, let's say, x raised to 7. Prime of x is equal to 7, put it here in front, 7x, then 7 minus 1. So you have 7x raised to 6. This is the derivative. What about we have a variable with a coefficient? Let's say the function is for x5. So all you have to do, prime of x is, again, put 5 here, 5 times 4, x, then 5 minus 1. Again, you have to put 5 here in front, so you will have 5 multiplied by the 4, and then x variable 5 minus 1. So you will have 20x raised to 4. That's the derivative of this function. Another example, let's say you have 2x7, 2x raised to 7. So let's get the derivative, f of prime x, 7, put it in front, 7 times 2x, then 7 minus 1, you will get 14x raised to 6. If ever, but this is not commonly given in my function, if you will be getting the instantaneous velocity, but if ever you encounter a radical sign or like a fractional exponent, let's say for example you will have to get the derivative of square root of x. Remember, prime of x, square root of x, square root could be written as 1/2, right? Raised to 1/2. So you can just rewrite this one, remove the radical sign here, and square root means raised to negative 1/2. Put that 1/2 in front. So you have 1/2 x raised to 1/2 minus 1. Let's try to get the answer of that 1/2. 1/2 minus 1. Then you will get negative 1/2. So your answer would be 1/2 x raised to negative 1/2. You can simplify it further. Let's say, for example, you have x squared over x squared. Actually, we can cancel it and we have 1 as our answer, right? And also, if we will be using the rule of exponent, let's say x squared and x squared, we can say x2 minus 2. So you will have x raised to 0. If you can see, same fractions here, answer 1, and then the answer is x is 0, raised to 0. So x raised to 0 is equal to 1. For any variable raised to 0, the answer is 1. We can write it as 1. So therefore, the answer for this, or the final answer for this function is, we will continue, since x0, x raised to 0 is equal to 1, so we can change this here into 1. So the answer is 1. Okay, let's do it again. 1 minus 1 is 0, so 1x over 0. And remember, any variable raised to 0 will become 1. So we can say, we can change x raised to 0 into 1. So our final answer will be 1. So the derivative of x is 1. What about 1 over x squared. F prime of x is equal to, we can rewrite this since it's in a fraction form to make it like uh, easy to perform. So we can do the reciprocal of it. So we can have x raised to negative 2, because x raised to negative 2, it is just equivalent to 1 over x squared. It's like this. So we can do it, the power rule here, negative 2, put it in front of x, so you can have negative 2x and then negative 2 minus 1. The answer is negative 2x, and remember, signs are the same, so we can add the value, the absolute value of it, following the sign, negative, and you will have negative 2 raised to negative 3. Uh-huh. So we can have another sample here. We have 3x squared. So all you have to do, f prime of x, you can transfer here to 2. Always remember, multiply by 3, and then x 2 minus 1. So the answer is 36x 1. Or it's okay not to put 1. It could be fine. X, 6x, that's the answer. For coefficient or for constant, what will be our derivative for constant without any variable x or any letters, for example? So prime of x is equal to, we can write 7x raised to 0, because according to the constant rule, any constant is equal to 0. So we can write 7 as 7x raised to 0, because if you will do the power rule, put 0 here, 0 times 7, and then 0 minus 1. The answer will be 0x negative 1. Or we can still evaluate it. Since you have negative 1 here, keep the coefficient and then multiplied it by the reciprocal of x raised to negative 1. So that's 1 of x. So 0 over x. Anything here in x variable, if you will divide it by 0, the answer is 0. So the f of x of our constant is 0. Any number, 1 to 9, or any constant number without variable. So our answer is 0. Last, we have this. Please be very careful with this. We have open and close parenthesis. So we will get the f prime of x of it. First thing is you have to distribute 3 here. So 4 raised to 3. And then x raised to 3. And let's apply power rule for each of the term here. So 4 times 4 times 4, that's 64. Then power rule, put it in front of x, 3x, and then 3 minus 1. You have 64 times 3x 2. And let's evaluate further. 64 times 3x squared. So you will have 92x squared. This is the derivative of 4x cubed. I hope you I hope you learned something. I hope you recall your power rule based on the examples I presented. All right, so let's have the position function here, and our position function with respect to time. We will be getting the derivatives of these two functions here. And remember, your instantaneous velocity is the first derivative of our position function. So it's the first derivative. If we will get the derivative, or if we calculated the derivative of these two functions here, yeah, we will we will find the instantaneous velocity. It's the first derivative of our function. So let's try to do the math here. Let's get the derivative of our position function here. So f prime of x is equal to, put 2 here in front of x, and then 2 minus 1 plus, it's understood we have 1 here, put it here, 1, and then multiplied by 2, and then x variable 1 minus 1 plus 0. Remember, I said 0 because constant of the variable of the, or constant variable in getting derivative, it is always 0. So let's have 0 instead of 1. Let's write 0 here. Let's simplify. 2x, 2 minus 1, that's going to be 1, or you can just simply not write 1 here. It's understood. Plus 1 times 2, it's 2x. 1 minus 1 is 0. And remember, if a variable is raised to 0, it is equal to 1. So we can further simplify our terms here. 2x plus 2, and we will change x to 1. So our derivative is 2x plus 2. What about this position function with respect to time? Let's get the derivative now. X prime of t, put 2 here in front. So 2 multiplied by negative 3, and then 2 minus 1. Plus 9, you have 1 here. So put that 1 in front of 9, multiplied by 9. And then t, 1 minus 1, plus constant, always 0, plus 0. Simplify. 2 times negative 3, it's negative 6. And then t squared minus 1, it's 1. Or again and again, you can simply not write 1 here, exponent 1. Plus 1 times 9, that's 9. T, 1 minus 1 is 0, remember? Any variable raised to 0, it's equal to 1. So we can simplify it further. 9, we will change t raised to 0 into 1. So our final answer is 6t plus 9. It's our derivative. I hope you got it right. Now we have a problem here. The position function of the particle moving along the x-axis is given by a function of x of t is equal to 3t squared plus 5. Let's say that's the function. And with time in seconds and the position in meters. That's the unit. These are the units involved here. We will get the average velocity, or our v, then average. And we need to find the instantaneous velocity at 1 second, instantaneous velocity at 2 seconds, and then at 3 seconds as well. By the way, the average velocity, we need to find it from this range or period, 1 second to 3 seconds. So in finding the average velocity, all you have to do is to substitute directly the given initial and final time to the position function. So in our problem, we need to find our average velocity from 1 second to 3 seconds. So we will directly plug in this 1 second and 3 second to our function. To get the average velocity, let's have first the position function. Let's copy it. You have to directly substitute to get the position function at 1 second. So at 1 second, all you have to do is to substitute 1 in our t variable here. So that's 1 squared plus 5. 3, 1 times 1, that's 1 plus 5. And then you have 3 times 1, 3 plus 5, it's 8. Remember, time is in seconds, on position it's in meter. So all you have to do is to use, since we're dealing with position with respect to time, so that's 8 meter. This is going to be your initial position, x sub I. Next, at 3 seconds, what will be the position of this moving particle here? So x with respect to t, it's 3t squared plus 5, but this time the value of t will be 3 at 3 seconds. So 3t, replace it with 3 squared plus 5. Then 3, get the squared first. 3 times 3 is 9 plus 5. 27 plus 5, it's 32 meter. And this will be your final position. Then to get the average velocity, remember the formula. It's just the change in position or displacement over change in time. So our change in position, x final minus x initial, over time final minus time initial. X X final will be 32 meters minus our initial position 8 meters over the time. Final time is 3 seconds minus 1 second. So 32 minus 8, it's 24 meters over 3 seconds minus 1 second, that's 2 seconds. And our answer will be 12 meter per second. That's the average velocity. Let's get the instantaneous velocity at 1 second. Remember, our instantaneous velocity is the first derivative of our position function. Derivative. Our position function, it's x of t is equal to 3t squared plus 5. So x prime of t, it's going to be put it here 2 times 3, then 2 minus 1 plus 5. Next, multiply it. 3 times 2, that's 60. 1, or we can just remove 1 here. And then our constant 5, constant will be 0. So plus 0, or we can just have 60 as our first derivative. So in that case, we can find the instantaneous velocity at 1 second. All you have to do is to substitute 1 to that t variable here. So at 1 second, our instantaneous velocity, it's gonna be 6t, right here. It's our first derivative. Then we will substitute 6 and then 1 second, and then the answer will be 6 seconds. And the unit, of course, since we're dealing with velocity, don't forget, you have to put it meter per second. 6 meter per second instead of 6 seconds, or what? Now, the v-ins at 2 seconds, it's going to be 6t, and then 6 times 2, you will have 612 meter per second. And the last one, we have our v-ins at 3 seconds. All you have to do is 6 times 3. That's from 6t, right? And then we will have 18 meter per second. These are our instantaneous velocity at 1 second. Positive, so it's going to the right, 6 meter per second. At 2 seconds is our instantaneous velocity, and at 3 seconds, this is our instantaneous velocity. We have this another problem here. The distance equation is provided by this function. X of t is equal to 2t squared plus 4t plus 3. Okay. It's squared. And let's get the following. The average velocity from 3 seconds to 7 seconds, the v-ins at 4s and the v-ins at 6s. Remember, our time is in seconds and then position is in meters. These are our units after we get the values of the following tasks here. So let's begin by getting the average velocity. To get the average velocity, do not forget the formula is just change in position, change in time, or change in displacement over change in time. We will just put the value of our time directly to our position function to get our initial position and the final position. So let's begin with at 3 seconds as our initial position. So x of 3, I'm looking at the function here. 2, we'll substitute 3, then squared plus 4, then times 3 plus 3. 2, always remember you have to square first values here. before you will multiply it by 2. Okay? 3 times 3, it's 9, plus 4 times 3 is 12, plus 3. So 2 times 9, it's 9, 18. 18 plus 12 plus 3, our answer would be 18 plus 12 plus 3. The answer is 33. Do not forget meters. This is our initial position. So what about at 7 seconds? This will be our final position. X 7 seconds. Still, we will be using the function. So 2 substitute 7 squared plus 4 substitute 7 plus 3. So again, before you will multiply it by 2, get the square of 7. 49 plus 7 times 4, 28, and then plus 3. 2 times 49, it's going to be 98 plus 28 plus 3. Plus 28 plus 3, we get 129. Don't forget the unit meters. So to get the average velocity is equal to change in x over change in time. So x final minus x initial, and then t final minus t initial. Our final, it's 129 meters minus our initial here, 33 meters. And final time, of course, it's 7 minus, this is our final time, and this is our initial time, so 3 seconds. So 129 minus 33. So you will have 96 meter, and then 4 seconds. 96 divided by 4, you'll get 24 meter per second. This is the average velocity from 3 to 7 seconds in this particular function here. Now we will be getting the average velocity. Now we will be getting the instantaneous velocity at 4 seconds and at 6 seconds. Okay, you can pause this video if you want to do it yourself, and then we will be comparing our answers later. Okay, feel free to pause the video. Remember, your instantaneous velocity is the first derivative of our function here. First derivative. So we will get the derivative. You'll get the derivative of the first derivative of our function here. So we have xt. I will just write it here or copy the function provided. Don't be confused. This is t. So x prime of t is equal to, put 2 here and then multiplied by 2, and then the time is 2 minus 1 plus 4. It's understood we have 1 here, so put 1 over here beside 4, and don't forget you will multiply it. Then t, 1 minus 1 plus constant will become 0. Simplify. 2 times 2, that's 4. T, 2 minus 1, that's 1, so it's okay not to put the power 1 here. Plus 1 times 4, it's 4. 1 minus 1 is 0. And remember, a variable raised to 0, it's 1. So we can further simplify it here. 40 plus 4 times 1, because t raised to 0, it's just 1. So our derivative will be this. Now we can get the v-ins at 4 seconds. We will be now using our first derivative here. Do not forget. So our v-ins is equal to 4t plus 4, and substitute 4 in our t variable. So you will have 4 here plus 4. 16, 4 times 4, 16 plus 4, then you will have 20 unit of your velocity meter per second. This is the velocity at 4 seconds. What about the velocity at 6 seconds? V ins at 6 seconds. So V, or instantaneous velocity, we will be using the derivative, the first derivative of our function, 4t plus 4. So just substitute 6 to the t variable here. So 6, 12, 18, 24 plus 4, you'll have 28. Don't forget the unit, meter per second. This is the instantaneous velocity going to the right, since it's positive, at 6 seconds.